In this video, we're going to talk about applications of quadratic equations, specifically centered around geometry applications. This problem says the width of a rectangular slab of concrete is 3 meters less than the length. The area of the slab is 28 square meters. And we need to find the dimensions of the rectangle. In other words, we need to find the length and the width. So when it comes to these type of problems, specifically where geometry is involved, I like to draw pictures. So here we have our rectangular slab of concrete, and we know that we're going to have a width and a width and a length and a length. But if we proceed with this problem using two different variables, an L for the length and a W for the width, we might be creating problems that are unnecessary. So let's do our best to use only one variable. The first sentence contains the information that we need to do that. It says the width of the rectangular slab of concrete. The width is, that means the width is equal to 3 meters less than the length. So that means the width is equal to 3 meters less than means 3 meters less than L. Or the width is the same thing as the length minus 3. So rather than using a W for the width, we're just going to use the expression L minus 3. And now we have one variable representing all the sides of our rectangle rather than two. The next thing I notice about this problem is in the second sentence. The area of the rectangle is 28 meters squared. And when it comes to rectangles, we know that area is equal to length times width. Or in our case, length times, and the width is L minus 3. So we'll have the area is equal to L times L minus 3. And we know that the area is 28 square meters. Now we have an equation that we can solve for L. First step in solving this equation is to get rid of the parentheses by distributing the L to the L minus 3. That gives us 28 is equal to L squared minus 3L. Now I notice that this is a quadratic equation. So let's solve it by factoring. Move the 28 from the left side of the equation to the right side of the equation by subtracting 28 from both sides. This gives us 0 is equal to L squared minus 3L minus 28. Continue solving by factoring the right side of the equation. L squared minus 3L minus 28 is a trinomial with a leading coefficient of 1 that factors into two binomials, the first of which is L minus 7 and the second of which is L plus 4. Now take each of those factors, set them equal to 0, and solve. That gives us L minus 7 equals 0 and L plus 4 equals 0. Solving the left equation, we find that L is equal to 7. And solving the right equation, we find that L is equal to negative 4. So these are the two solutions to that quadratic equation. 0 equals L squared minus 3L minus 28. Now, while both of these are solutions to our quadratic equation, they're not both solutions to our application problem. Sometimes when we apply mathematics to the real world, we have to use some common sense to determine if the solutions are applicable to our situation. Well, the first solution is the length is equal to 7. 7 seems to be a reasonable solution for the length of a rectangular slab of concrete. But let's look at the solution negative 4. The length of a slab of concrete cannot be negative 4 anything. Negative 4 meters, negative 4 yards, negative 4 anything. Have you ever taken a tape measure to measure something and said, oh, that's negative 4 inches long? No, that doesn't make sense. So while negative 4 is a solution to our quadratic equation, it is not a reasonable solution to our particular application problem. So therefore, the only reasonable solution is the length must be 7. If our length is 7, the width is the length minus 3. So that means that the width must be 7 minus 3, or 4. And that means that our room, or rather this rectangular slab of concrete, is 7 meters long and 4 meters wide, or has the dimensions of 7 by 4. This problem says the base of a triangle is 2 feet less than 4 times the height. If the area of the triangle is 6 square feet, find the base and the height. So here again, because this problem is involving geometry, let's draw a triangle. The base of a triangle, or the base of this particular triangle specifically, is this length. And the height is this length. Now that we have a good idea of what our base is and what our height is, let's go back to the problem and see what other useful information might be there. One of the first things I notice is that the area of this triangle is 6 square feet. That's a hint that I'm going to need to know the area formula for a triangle. And the area of a triangle is equal to 1/2 the base times the height. So we have 6 is equal to 1/2 the base times the height. Now, for simplification purposes, I'm going to go ahead and multiply both sides of this equation by 2 to get rid of the 1/2 on the right side. If we multiply the left side by 2, we get 12. And if we multiply the right side by 2, 1/2 times 2 is just 1, and we just have base times height. So we know in this particular example that the base times the height has to be 12. Well, we also know that the base is, those words are telling us that the base, b, is equal to something. Well, what is the base equal to? It's equal to 2 feet less than 4 times the height. So here they're giving us the base, but they're using the height to describe the base. So I'm going to let h equal the height. Well, then what is the base equal to? The base is 2 feet less. So we know we're going to be taking 2 away from something. So let's go ahead and subtract 2. 2 feet less than what? Well, 4 times the height. Well, if the height is h, 4 times the height would be 4h. So the base is equal to 4h minus 2. So here again, rather than using 2 different variables, b and h, we're able to express the base and the height using one variable, h. So if 12 is equal to the base times the height, then 12 is equal to h times 4h minus 2, which is the base times the height. Let's solve this equation by getting rid of the parentheses first. Let's distribute the h to the 4h and to the minus 2. That gives us 12 is equal to 4h squared minus 2h. This is a quadratic equation, so let's get all of our terms on one side, 0 on the other. Subtract 12 from the left side and the right side of this equation. And that gives us 0 equals 4h squared minus 2h minus 12. Now let's factor the right side. There's a GCF of 2. Factoring out the GCF gives us 2 times the trinomial 2h squared minus h minus 6. We have to continue factoring the 2h squared minus h minus 6 because it's a trinomial with a leading coefficient that's not 1. So we'll use the AC method to continue factoring. Using the AC method, we'll find that 2h squared minus h minus 6 factors into 2h plus 3 times h minus 2. Now that we've got the right side completely factored, let's take each factor that contains a variable and set it equal to 0. That gives us 2h plus 3 equals 0 and h minus 2 equals 0. And now let's solve both of those linear equations. That gives us h equals negative 3/2 and 2. But here again, because we're solving an application problem, we have to determine which of these solutions makes sense. Well, obviously it doesn't make sense for the height of a triangle, or the height of anything for that matter, to be a negative value. So negative 3/2 is not a likely solution for my application problem. 2, however, is. So if 2 is the height, what's the base? Well, the base is equal to 4 times the height minus 2, which would be equal to 4 times 2, because the height is 2, minus 2, which is 8 minus 2, which is 6. So the height is 2 and the base is 6.